Good morning to Madam Rose and to whoever who are watching. Today our group will be presenting about integral. My name is Cyril Gary Jr. and number matrix 07DKA23F2055.
Good. Hi, my name is Charles Ting Chui. My matrix number are 07DKA23F2005.
My name is Wang Zilin and my matrix number goes by 07DKA23F2035.
Hi, Assalamualaikum. My name is Ahmad Zulfadli bin Ruslan and my matrix number is 07DK23F2021.
Moving to introduction, in civil engineering, the concept of integral can refer to several mathematical methods or techniques used to model, analyze, and solve problems related to physical structure, fluid dynamics, transportation system, and other areas. The most common use of integral in civil engineering is in structural analysis, fluid mechanics, geotechnical engineering, and in the modeling of various phenomena such as stress, strain, heat flow, and material properties. Alright, we will be moving on to basic definition of integral. An integral is a fundamental mathematical operation used to calculate quantities such as areas, under curve, volumes, and accumulated value. It is essential the reverse operation of differentiation and is often used to solve problems involving continuous quantities. Mathematically, an integral is expressed as f x dx. This notation represents the process of summing of or accumulating a function fx xx over a particular range. In civil engineering, integrals are used to calculate quantities that involves accumulation such as total load, energy, and material.
So, jump to application of integral in civil engineering. First, structural analysis. In structural engineering, integrals are frequently used to compute the deflection of beams, bending moments, and shear force, particularly for continuous structures. The key equation for the deformation of beams and analysis of stresses can be derived using integral calculus. To find the deflection, this equation is integrated often twice to yield an expression for the beam's displacement. Second, fluid mechanics. Integrals are also used in analysis of fluids, especially in the calculation of flow rates, pressure drops, and fluid velocities in open channel flow or pipe flow. For example, the velocity profile of a fluid can be described by an integral equation. A common equation in fluid mechanics that uses integral is a de Bernoulli equation, which relates the velocity, pressure, and height in a flowing fluid. Integrals are often used to compute quantities like the total engine energy or total volume of fluid flowing through a system over a given period. And the third one, geotechnical engineering. In geotechnical engineering, integrals are used to model and analyze the stress distribution in soil and rock formation. This distribution of stress in a foundation or the settlement of a structure due to loading can be determined using integration, and the total settlement of a foundation can be calculated by integration the pressure distribution over the area of contact.
Moving on to our next question. Diagram below shows a region which is enclosed by a curve which is y equals to x power of 2 and a line which is y equals to x plus 2 that is rotated through 360 on the x-axis. Show the solution to find the volume of the solid form. After looking at our question, there is 6 steps that we must follow to find the solution for our question. Step number 1 is to identify the graph. Identify the structure of the graph to indicate whether the curve is above the line or the opposite. From the diagram below, we can observe that the line is above the curve, which will be essential for the next step to find the solution. For the next step, list out the formula. After identifying the graph, it is important to list out the formula to avoid making mistakes later on. We can see that x equals to 2 and x equals to -1. Therefore, it can be listed as below.
Thank you, Charles, for his previous presentation. So now we move to the third step, which is placing the equation. So at this point, we do understand now that integral y squared is equal to x squared from previous mentioned equation. So we will be placing the equation, which is from the diagram above that we see from the line and the curve. So we begin from the line first, and it is above the curve. So since x is equals x plus 2, now we can place into the equation to find our C line. So as we can see here, as we know that integral y squared is equals to x squared, and we now know that our x is equals to x plus 2. So we basically just put 2 in there. So where the 2 and -1 came from is from the previous mentioned diagrams, where we see that the line is placed between the -1 and 2. So that will become our value for later on. So after we make the integral, we shall proceed with the integration of the equation. So we can see here, which is pi, which is inside the bracket, x plus 2 in the power of 2 plus 1, and the denominator 2 proceed with 2 plus 1 as well, and outside that the place value, which equals to pi bracket x plus 2 in the power of 3 and over 3 and 2 -1 as a place value. So from this place value, we now understand that x1 is equals 2 and x2 is equals to -1. So by putting it inside of the equation after we finish integration, we get this 2 plus 2 in the power of 3 over 3 minus with pi, which bracket close, -1 plus 2 in the power of 3 over 3. So what we get from both of this answer is 21.333 pi minus by 0.333 pi, which equals to our 21 pi. Now we're not done yet. That is only our C line. We haven't yet calculated our C curve. So by doing the same thing, we shall proceed with the calculation. So again, integration y squared is equals to x squared. Now we proceed there. Since this time our x is equals to x squared, so the integration of y squared is equals to 2 over -1 as a place value pi x in the power of 4. So we do it as usual. Pi inside of the bracket, we have a x in the power of 4 plus 1 over 4 plus 1, and outside of this place value, which equals to pi bracket x in the power of 5 over 5, which we will also have its own place value. So by doing the same thing from previous calculation of our C line, we can find our C curve. So when x1 is equals to 2 and x2 equals to -1, we got the answer of pi bracket 2 in the power of 5 over 5 minus with pi -1 in the power of 5 divided by 5, which we get the combined answer of 6.4 pi plus 0.2 pi. We get 6.6 pi. And now we shall have our final calculation. So from previously mention of the formula, we did mention that since the line is above the curve, it should be line deduct from the curve. So after finding C line and C curve, we can finalize the calculation by deducting both of these calculation from previous mentioned equation of C line minus by C curve. So C line minus by C curve. So C line we have So we have finally reached our final step, which is making our conclusion, which we can finally conclude that the solution of this volume is either 72 over 5 pi, 14.4 pi, or integrate the pi into the calculation is 45.237 unit cubic. And that's all from me. I shall continue this presentation lastly to Ahmad. Thank you.
Hi, it's me again. So let's jump to conclusion. The use of integral in civil engineering is extensive and essential for the design, analysis, and optimization of various engineering systems, from the analysis of force in structures to the modeling of traffic flow. The integral provides a tool for understanding and calculating continuous quantities that describe the behavior of material, fluid, and system in the built environment. Understanding how to apply integral in civil engineering enables engineers to create more accurate models, improve safety, and optimize the performance of infrastructure projects. That's all from us. Thank you.